Go ahead and take a look at this. So anyway, what this is pertaining to is the biological actions of insulin. And then, of course, once we have problems with insulin, then we're going to have problems with glucose. And then, of course, that would be diabetes, right? So that's why this is important to really understand what's going on metabolically with diabetes, right? All right, so now let's look what's normal, right? Okay, so in healthy people, of course, we consume carbohydrates. So our carbohydrates is going to be coming from our diet, right? So let's say we consume our carbohydrates, and then of course, carbohydrates are going to be broken down to glucose. And then of course, once they get broken down to glucose, it's going to increase your blood glucose, right? So your glucose is going to rise in your blood. Okay, and then once the glucose rises in your blood, and it's going to stimulate those beta cells in your liver to release insulin. Okay, and then of course with insulin, this is what's going to be very important. And of course, it's a hormone, it's a protein, so it's going to send a message to all these different tissues. Now for glucose uptake, remember there's only two primary tissues that require insulin for glucose uptake, and that's the skeletal muscle and the adipose tissue, right? So in terms of insulin, first thing it's going to do is it's going to travel to our skeletal cells, and then of course in our skeletal cells, we have an insulin receptor, right? We know all this. We learned this a long time ago. So there's your insulin receptor there. Okay, and then of course, insulin is going to bind to it. Okay, so it's going to stimulate, or it's going to activate that insulin receptor. And of course, that's going to send a message, going to send a signal to our glucose transporters. And of course, the ones that are muscle, these are called GLUT4. And of course, these are transport proteins. So what these GLUT4s are going to do is they're going to translocate up to the cell surface, right? And then this is where the blood is. So here's all your blood glucose. And it's going to allow blood glucose to enter, right, the skeletal muscles. And when it enters the skeletal muscles, that glucose, of course, can be used by the skeletal muscles for energy and all kinds of other things. But then, of course, we're going to store it as glycogen. Okay, and again, of your blood glucose, this is 75% of your blood glucose, of that rise in your blood glucose from eating. 75% of your blood glucose is going to be taken up by your skeletal muscle. So this is going to be very significant in terms of regulating your blood glucose, right? Because let's say you went 100, these are arbitrary numbers. Let's say you went 100 milligrams over what your glucose should be, right? So 75 milligrams of that is going to be removed by the skeletal muscle in response to insulin. So that's a big chunk of the blood glucose, right? Now with insulin, what else it's going to do is it's going to prohibit glycogen from being broken down. Because remember, if glycogen is being broken down, it's going to release glucose. So when you have not eaten, right? But in this case, remember your blood glucose levels are going to be high. Okay, so we don't want this to happen. So insulin is going to inhibit this. Okay, so it's going to prevent that from happening, which is good because again, if our blood glucose levels are already high, we don't want it to go higher, right? So insulin is going to ensure that. Right, so that pretty much takes care of the skeletal muscle. in terms of what's considered normal. But now also here in your adipose cells, this is the beige here, then you have an enzyme, right? This is called LPL. I hope you learned this, lipoprotein lipase. And since it is considered lipoprotein lipase, it's going to break down lipids like triglycerides that are in your blood. And of course, in terms of these triglycerides that are in your blood, again, this is either when you haven't eaten, or when you've eaten a lot. Remember, your chylomicrons are going to be high in triglycerides from your diet. And when you have not eaten, then your triglycerides are going to be high, and that's going to be VLDL. But regardless, this enzyme, LPL, lipoprotein lipase, it requires insulin. And then what this LPL is going to do is going to activate it. So now your triglycerides, okay, are going to be broken down. It's going to be broken down to 3 fatty acids. Okay, and then of course, with these 3 fatty acids, they're going to enter our adipose tissue, and we're going to have our 3 fatty acids, and they're going to get reesterified into triglyceride synthesis, right? And then we can store it. And again, this is what insulin is doing. Okay, it's stimulating all this. So it's stimulating LPL, which is an enzyme, and it's also stimulating triglyceride synthesis. Okay, now on the other hand, again, since we're in surplus, right? Since we're trying to store this long-term energy stores in the form of triglycerides, we don't want to break it down. So sometimes when we need energy, we're going to break down those triglycerides to fatty acids, right? And then of course, those fatty acids are going to enter circulation. Well, of course, we don't want that to happen. So what insulin is going to do, it's going to prevent the breakdown of triglycerides, right? That makes sense to me, because remember, insulin, we're building things up. And once you build it, you don't want to tear it down. So in the muscles, we're making glycogen, right? And we don't want to break it down. Once you build it, that doesn't make sense. So in here, we're storing triglyceride synthesis. So again, the bottom line, insulin is going to promote glycogen synthesis, which means we store glucose, and insulin is going to promote triglyceride storage, which means that it's going to lower the fats that are in your blood. These are all good things, right? Until we really need energy, but don't think about that, okay? All right, so another thing is here in our liver. So now let's talk about the liver. So in the liver, one of the things that the liver does is gluconeogenesis, right? So, it does a million things, but let's just, in terms of how it's relevant for this discussion. So anyway, in your liver, of course, we have gluconeogenesis, right? And that's creation of new glucose. Right? Creation of new glucose, right? So in terms of the process of gluconeogenesis, well, what we do is we will use either amino acids or lactate. I'm just going to use amino acids, but it could be lactate. And then, of course, these amino acids are a substrate. So you have this carbon skeleton. You know this story. And then, of course, we need to do this. We already removed that nitrogen, right? So now we have the carbon skeleton, and that's what's going to be used to make glucose, right? And then, of course, this glucose can lead to what we call hepatic, meaning your liver, glucose production. Okay, so again, do we want the liver to make more glucose? when glucose levels are already high? No. So thank goodness we got insulin. So what insulin is going to do is it's going to inhibit this. Okay, so it's going to inhibit gluconeogenesis because again, we don't want to make glucose when your glucose levels are so high. We want to prevent making new glucose. We need to turn the faucet off. When the sink's full of water, that would be your blood. It's full of glucose. You turn the faucet off. So that's what we're doing with the liver. Okay. Okay, so that's what's going on here. So so we need to need to understand this, because what we're going to do is now we're going to reach the situation to where your cells are not responding to insulin, or your pancreas cannot produce insulin. And then as a result, we're going to lead to very high blood glucose levels, right? Okay. All right, so now let's use a different color, right? In terms of the pathology here, okay? And I'll use red. Okay, so now let's say, for example, insulin is not working correctly, right? Okay, so let's say we're insensitive to insulin, or those cells are not responding to it. Well, let's start here in terms of the skeletal muscle. So let's say, for example, someone is obese. Remember, that's a big risk factor for type 2 diabetes. So now let's say you have a lot of adipose tissue, right? Okay, and then of course, this will be reflected by either a large waist circumference, WC is waist circumference, or an increase in BMI, which means over 25 or over 30, right? Okay, so now this adipose tissue, right, when it's in excess, it's going to produce cytokines. Okay, and what these cytokines, what these are going to do, or they're going to lead to inflammation, and they're going to damage the insulin receptor. Okay, in this case, right? So this isn't going to work. So now that's not going to work. So now, since that's not going to work, and now there's no message, right? So now there's no message there's no message to send to the GLUT4s to take up glucose. So if there's no message, or we're not receiving the message, that's not going to work. And then, of course, what happens is going to lead to a surplus of blood glucose. Okay, so all kinds of blood glucose is going to be high, right? So here I'll just put up increase in blood glucose, big time. And remember, the red here is going to represent either insulin insensitivity or either insulin sensitivity, or there's no insulin. I might as well redo it. I'm just trying to emphasize. So now we're going to get an increase in our blood glucose. I'm just going to abbreviate it BG, B glucose, right? So now we're going to get this elevation of blood glucose. Now we're going to start running into problems, right? So that's good. That's going to be our first problem. So with this big surplus of glucose, so let's start off with glucose. And what's going to happen is here, for example, we have our red blood cells. Now, in terms of our red blood cells, what these have, they have a glucose transporter called GLUT1. Okay. Now, remember, for glucose uptake, we don't need insulin for the red blood cells. So now all that surplus of glucose is going to go into the red blood cells, and then that's where it's going to acetylate the hemoglobin. Right? So now you're going to get a rise in your A1C. Okay? And of course, that's over long term, 90 to 120 days. Okay, so that's one thing that's going to happen with this surplus of glucose. Okay, so of course, this is glucose. It's entering the cell here. But we also, in this case, we have our nephrons, right? These are our kidney cells. So now we have all this glucose. It's also going to be taken up by the nephrons because with the nephrons or the kidneys, here I'll just use kidneys. Artery racing. So now this glucose is going to be taken up by this because in your kidneys you have GLUT2, and again, it does not require insulin for glucose uptake. Okay, so the really only tissue that requires insulin for glucose uptake at this point is going to be your skeletal tissue, and then of course your adipose tissue. But the skeletal tissue is what's going to be the emphasis, right? So insulin's not working, so now there's more glucose into the blood. However, since GLUT1 does not require insulin, more glucose is going to be taken up by the red blood cells, and it's going to acetylate hemoglobin. Also, more glucose is going to be taken up by the kidneys because it expresses GLUT2, which does not require insulin. Okay. And then, of course, what that's going to do is lead to advanced glycation end products. And when you get the advanced glycation end products, then what do you get? Then you get neuropathy, which is a kidney disease. Okay. All right. Now, also your nerves, right? So now your neurons, like your nerve system, same thing. Well, your nerve cells, your neurons, they're going to have GLUT3. And now I'm not going to ask you the name of these GLUTs. What I want you to do is understand that these glucose transporters in these tissues do not require insulin. Okay. So since it, and this is your neurons, or let's say your nerves. So same thing, all that glucose is in our blood. It's going to be taken up by those cells, and same thing, we're going to get those advanced glycation end products, and that's what's going to damage your nerve cells, and it's going to damage your kidney cells. And then in this case, oh, my bad, neuropathy you would get here. Kidneys is nephropathy. That is so my bad. Nephropathy, nephrons, your kidneys, nephropathy. And then, of course, neuropathy. And then, of course, it could also be your retina, and et cetera, et cetera, et cetera. Okay. Right. So again, what's going to be our main goal here? We need to get that blood glucose levels down, right? So all this stuff doesn't happen, okay? And then another thing, now let's talk about the lipids, okay? So now with the lipids, now let's go there. So here, for example, insulin, talking about here, insulin stimulates LPL, which breaks down triglycerides to 3 fatty acids. But if LPL is not being, because remember, this is in your adipose tissue, if it's not responding to the insulin, then this isn't going to happen. And then it can perhaps elevate your triglycerides, right? Okay. And then also, since insulin is not working, so instead of now your triglycerides, they're going to be breaking down very rapidly. So now that's not going to happen. So now you're going to have more that inhibition, meaning prevention of breaking down your triglycerides, not going to happen. So now it's actually going to be stimulating, sort of. I mean, you can look at it that way. It's not really stimulation, but anyway. So the triglycerides start increasing your fatty acids. Now your fatty acids are going to increase in your blood. And guess where these are going to go to? Here comes your triglycerides. It's going to go right back to your liver. There's your triglycerides. You use fatty acids, guess where they're going to go back to? Well, we're going to take a shortcut through the pancreas. Right? And then they're going to be, in terms of fatty acids. And then guess what this can lead to? Fatty liver disease. Who are at high risk of developing fatty liver disease, right? So again, it could be, in this case, this would be non-alcohol fatty liver disease. Right? And that's pertaining to the lipids, right? All right, so that's pretty much it. So make sure you know this, because I think there's like 7 or 8 questions that I'm asking you about what's going to happen. Right? I mean, what would you predict in terms of these metabolic pathways? Because that's what I want you to understand, right? So of course, with the so because of all this, the bottom line, clinically speaking, we're going to see hyperglycemia, which is high blood glucose. We're going to see dyslipidemia with diabetes. Which means you're going to have low HDL and you're going to have high LDL. And we're going to get into all those numbers when we get into heart disease next. Okay. And then, of course, think about the chronic complications. And those are over there on the left, right? The nephropathy, neuropathy, and then of course you could even have retinopathy. You can have cardiomyopathy, right? All those. All right. Okay, so let's go ahead and summarize this real quick. Okay, normally what happens is your blood glucose, it rises, and that's going to stimulate your pancreas to release insulin. When insulin is released, it's going to stimulate your skeletal muscles to remove glucose from the blood. And when glucose is removed from the blood by the muscles, it's going to be stored as glycogen. And then insulin will also go to your adipose tissue, where it's going to activate lipoprotein lipase, and you're going to break down triglycerides so you can take them up by the adipose tissue and you can store those triglycerides, right, for future use. Just like with glucose, you're storing it for future use. Okay. And then finally, insulin is going to go to the liver, and it's going to inhibit or prevent making new glucose, right? So, and then, so what happens is when your cells are not responding to insulin, or you do not have insulin, then of course, glucose cannot be removed from the blood by the skeletal cells, especially. And as a result, your blood glucose levels are going to go very, very high, and that's hyperglycemia. Also, what's going to happen is now your liver will start making glucose, and your hepatic glucose production will increase, and then that's going to increase your blood glucose. All right. Oh, and I didn't mention that. So here, I think maybe I did, but anyway. So now that's not going to. So now you're going to increase your hepatic glucose production. Now regarding your fats, and of course, LPL doesn't work. Since LPL is not responding to insulin, or there's lack of insulin, and that's going to elevate your blood lipids, and those lipids, such as triglycerides, are going to travel to your liver. And what's going to happen is your fat tissue is going to start breaking down more fat, and that's going to allow fatty acids to go to your liver, and then that can lead to non-alcohol fatty liver disease. Okay. Now the consequences of all this, right, is going to be the high glucose can lead to glycation, advanced glycated end products in your kidneys and your nerves and your eyes, and it can lead to kidney disease, nerve conditions like paresthesia, and it can lead to blindness. right? And then, of course, in your red blood cells, we're going to use A1C, number one, diagnostically to diagnose someone for diabetes. And then secondly, just to monitor it for long-term monitoring for compliance or long-term compliance of managing the blood glucose, okay? All right, and I think that pretty much is it. And then, of course, you could all watch it again. All right, make sure you know this. I'm telling you, that may be even, let's see, I know just on one part of it, there's at least 7 or 8. And then I know then there may be a few questions throughout the exam, okay?